Good day, everybody, especially to our panelists. I am Michelle Rabanilla and I wish you a pleasant day. We will present our proposed study with my group mates.
I'm Erin Maranyon.
I am Cornelison Santos.
I'm John Ray Makirang.
I am Ronan S. Marquez, and we will be presenting our proposed project
Entitled Jaula de Amor, a smart bird cage with monitoring and management system for Agapornis fishery. In the introduction, it is said that people get a pet for companionship and protection for the house or property. Also, half of the UK's adult population is worried about leaving their pets at home when working, which can also be applied to all pet owners worldwide. And according to a recent Rakuten Insight survey in the Philippines in 2021, 10% of Filipinos owns a bird. These facts in mind, and that only a few innovations for pet birds have been made, proponents propose the smart cage.
During the COVID pandemic, there was a noticeable increase in pet ownership, placing the bird in the top 3 of the most popular pet in the Philippines. Smart cage. The proposed Jaula de Amor, a smart bird cage with monitoring and management system for Agapornis fishery, is specifically designed to help in monitoring and managing the Agapornis fishery. Agapornis fishery. Agapornis fishery is defined as a type of bird originated from Africa, also known as lovebird, a type of bird with gorgeous feather colors and lovely sound. Pets' basic needs. SKIP 2018 defined the 5 basic needs of pets: water, food, oxygen, temperature, and habitat. Feeding system. One of the features of this cage is the feeding system, where the time and amount of food will be monitored. Temperature. The side cage will be great in monitoring and the temperature of the bird. Cage cleaning. It is indispensable to keep cages as clean as possible. The reason why Jaula de Amor will have its cage cleaning feature. That's all for the background of the study.
objective of the study. The main objective of our study is to develop a smart bird cage with monitoring and management system for Agapornis fishery. Specifically, it aims to first to design a smart bird cage with IoT using Arduino. The bird owners can control the cage functions anytime and anywhere as long as they are connected to the internet. Second is to develop a monitoring system through mobile application. This will enable the bird owners to monitor the ambient temperature around the cage and also monitor the bird through video surveillance. Third is to conduct a system usability test and determine the system's level in terms of functionality, efficiency, and reliability. And lastly is to evaluate the effectiveness of the developed system by survey questionnaire.
Scope and delimitation of the study. In this study, the researcher aims to create a smart cage system for Agapornis fishery. However, the researcher delimited the following factors. In monitoring the lovebird, the researcher input a camera in cage. This device serves no other purpose but to capture live footage. Upon feeding of lovebird, the system has a device that can release food at a predetermined time. The amount of food can adjust depends on how many lovebirds are in cage. In regulating water, the drinking bowl can only hold a maximum of 250 ml. Presence of bird dropping in bowl and other that influence potability of water was not into consideration. In controlling temperature, the researcher have a device inside cage that can detect the ambient temperature and relative humidity. And if temperature hits 25 degrees Celsius below, incandescent lamp will turn on. Cage ventilation is not considered in this study, since the system only uses a cooling fan. Next, since natural sunlight gives nutrition to the bird, the cage has alternative sunlight and it is a full spectrum light for helping the bird to regulate their body clock. Next, the researcher implemented a featured treat system where if the bird is in the swing for 5 seconds, ultrasonic will trigger giving a foods. It will triggered once a day only. In cage cleaning, in bottom part of cages, there is a conveyor with brush that covers one side of cage and rotates till it reaches opposite side. The device was modified so that it can control two applications to set time when will the conveyor will be active. The study does not take full cage cleaning into consideration. This study is just for Gapornis fishery and no other bird species included. Also, maintenance of hardware materials and waste disposal were not taken into account. This study, this, this study did not address the power source during the outage as truly, given that the cage was designed to give beauty and decor of home, it must be placed inside the house of pet owner.
Significance of the study. Jaula de Amor aims to give ease to the life of the bird owner, assist the bird breeder, and give extra care to their lovebirds. With a bird cage controlled by an application and autonomous, it can give an extra hand to the owner and breeder to take care of their lovebirds and experience a comfortable life. So specifically, Jaula de Amor will benefit the bird owner, the bird breeder, and a future researcher.
The conceptual framework of the study consists of relevant variables and maps out how they relate to the study. The conceptual framework consists of three main phases, which are inputs, process, and expected output of the study, where developmental research methodology will be used since it encompasses system analysis, design, implementation, and maintenance. For the input, proponents needs to acquire programming, electrical, and electronic proficiency skills to create our proposed study. To create the system software, requirements such as the C++ language, the Arduino environment, and the Arduino Studio environment are needed. In the system hardware, the requirements are a microcontroller Arduino Uno R3, sensors such as ultrasonic and DHT11, a real-time clock DS3231, an ESP32 camera, a Wi-Fi module node MCU, servo and stepper motors, a full spectrum light, a warm bulb, and a fan. For the process, an agile method was used, which encompasses requirement analysis, system design, implementation, integration and testing, and deployment. In the requirement analysis, the proponents would gather information to the target respondents. Also, device measurement is necessary to fit the required hardware components. Problem identification is also considered to identify and evaluate a potential problem and generate possible solutions. Next is hardware and software design and prototyping, where the process of designing a system architecture, components, and interfaces takes place. After that, the implementation, software encoding, and development would start. Then, integration and testing, where proponents would address the possible errors and solve them. Lastly, the deployment, where proponents will perform final testing on the proposed project to check if it is fully complete and functional, and then deploy the system to the user. Finally, the output would be a Jaula de Amor, a smart bird cage with monitoring and management system for agapornis fishery.
The system design. The figure shown is the visual representation of how our system will work. Our project will utilize the Arduino Uno as the main board of our system. This is where the different types of sensor are connected, such as the DHT11, a temperature and humidity sensor, a ultrasonic sensor which can detect motion, a DS3231, a real-time clock, which will provide our system a time input. Next is the actuator of our system. We will utilize some relay boards for us to control the output devices, such as the heat lamps and full spectrum light. We will also use servo motors that is connected to the containers of the food, water, and treat of the bird, and a stepper motor that is connected to the conveyor of the cage. We will also use a ESP32 camera, which will provide a real-time video surveillance to the bird owners, and ESP8266 node MCU, which will establish a connection to our mobile application through the internet. Next is the block diagram of our system. Our system have three main inputs, which are temperature, motion, and time, which can be detected by our sensor, and the Arduino board will utilize these inputs and act accordingly to the predetermined function set in the software. If certain condition is reached, the Arduino board will send signals to the actuator to activate our output devices. And the node MCU will have two-way connection with the Arduino board for them to communicate in order to provide the bird owners the status related to the cage and display it to the mobile application of our system.
And that is Jaula de Amor, a smart bird cage with monitoring and management system for agapornis fishery. Thank you for listening to our virtual presentation, and now, this meeting is open for questions, suggestions, and clarifications. And that would be all. Thank you.